Given this equation, 2 raised to the power of x minus 4 raised to the power of 3 plus 4 raised to the power of x minus 2 raised to the power of 3 equals 4 raised to the power of x plus 2 raised to the power of x minus 6 raised to the power of 3, then also given that x is a real number, then the goal of course in this question is to find the value or values of x that satisfies this equation. Now pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. So given this equation, the goal is to find the value of x. Now, what we're going to do to answer this kind of question is to notice something. Now, take note. When we let this part be equal to a and this part be equal to b, take note, when we add a and b, we have 4 raised to the power of x plus 2 raised to the power of x, and negative 4 plus negative 2 will give us negative 6. Therefore, the right-hand side of our equation simply equal to a plus b. So, our equation now becomes a cubed plus b cubed equals a plus b raised to the power of 3. And now, if we want to expand a plus b raised to the power of 3, we will use the Pascal's triangle. And this Pascal's triangle, the first row says that if we have a plus b raised to the power of 0 must be equal to 1. The second row says that if we have a plus b raised to the power of 1, the value is a plus b, or simply the numerical coefficient are 1 and 1. Now this is true. The third line, if we have a plus b raised to the power of 2, we have a squared plus 2ab plus b squared, or simply the numerical coefficients are 1, 2, and 1. Now, if we extend this, we get also a plus b raised to the power of 3 and a plus b raised to the power of 4. But in this question, we want this identity a plus b raised to the power of 3. So we will use this identity to answer this question. Now, the left-hand side of our equation, rather the right-hand side of our equation, can be written as a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, if we subtract a cubed on both sides, they are gone. This is just 0. And if we subtract b cubed on both sides, this is also 0. So the resulting equations, just 0 equals 3a squared b plus 3ab squared. And we can factor out the common factor of 3ab. If we do that, we get 3ab multiplied by a plus b. Now, let's focus on this result. Because we know the value of a, the value of b, and the value of a plus b. They are 2 raised to the power of x minus 4, 4 raised to the power of x minus 2, and 4 raised to the power of x plus 2 raised to the power of x minus 6. And then, since we have a constant right over here, so let's divide both sides by 3, and we have 0 equals this a, b, and a plus b. Now, let's focus on this result. Since it is equal to 0, it follows that at least one of them must be equal to 0, or we have the 0 property. So we can say 2 raised to the power of x minus 4 equals to 0, the first factor, or 4 raised to the power of x minus 2 equals 0, the second factor, and the third factor, 4 raised to the power of x plus 2 raised to the power of x minus 6 equals 0. Now, let's start with the first case. So let's solve for the value of x. Add 4 on both sides. We have 2 raised to the power of x equals 4. This 4, we can rewrite this as 2 squared. They have the same base, equal expression, so we can say that their exponent must be equal, or simply we have x equals 2. So we found one real value of x that satisfies this equation. Now, how about on the second case? So add 2 on both sides. This 4 raised to the power of x can be written as 2 raised to the power of 2x. And these 2, we can rewrite this as 2 raised to the power of 1. Again, equal expression, equal bases, so their exponent must be equal. So 2x equals 1, or we get that x equals 1 over 2. So we have the second value of x that satisfies this equation. Now we found 2 real values of x that satisfies this equation. Now let's have the third case, but we want some space for this case. And now let's continue. 4 raised to the power of x, we can rewrite this as 2 raised to the power of x raised to the power of 2. Now let t be equal to 2 raised to the power of x because we have here same expression. And if we do that, we have t squared plus t minus 6 equals 0. So this is simply a quadratic equation in terms of t. Now we can factor this out nicely as t plus 3 multiplied by t minus 2 equals 0. Again, this is equal to 0. So using the 0 property, we can say that t plus 3 equals 0 or t minus 2 equals 0. But we don't want the value of t. We want the value of x. So let's replace all of this t with 2 raised to the power of x. Now let's solve for the first case. Subtract 3 on both sides. And take note, 2 raised to the power of x, since x is a real number, 2 raised to the power of x is always positive. So it cannot be a negative number. Therefore, in this first case, we don't have a real solution for x. Now, how about on the second case? Add 2 on both sides. And these 2 on the right-hand side, we can rewrite this as 2 raised to the power of 1. Therefore, we can say that x equals 1. And we found the last value of x, real value of x that satisfies this equation. Therefore, given this equation, where x is a real number, we found 3 possible values of x. We have 2, 1 over 2, and 1. And of course, we need to double check if those answers is correct. So let's check. Now, if x is equal to 1, we get 0 equals 0. Now, if x equals 2, we get on the left side 2,744 and on the right-hand side 2,744. And if x equals 1/2, the left side and the right-hand side equals to 50 times square root of 2 minus 88. Therefore, these 3 values of x really satisfies our equation. So given this equation where x is a real number, so we found 3 real values of x that satisfies this equation. The first one is x equals 2, x equals 1/2, or x equals 1. And as always, we are